My name is Chris Lee. My student number is S2248178878. This is Integrated Environmental Monitoring. For this task, we have two different types of sensors integrated into one circuit. That is the DHT22 sensor, which is a temperature and humidity sensor, and the same soil moisture sensor from the last task. In terms of hardware, we have a number of jumper cables. We have the DHT22 sensor, the soil moisture sensor, two LEDs, two 220 ohm resistors, one 10k ohm resistor, the same Arduino microcontroller that we've been using, and the same USB Type A to Type B. Now, the soil moisture sensor's SIG terminal is connected to A0, so that is the analog channel of our Arduino. We're using the yellow jumper cable for that. The ground for this is connected to the negative channel of the breadboard, which is the brown cable, and the blue, which is the VCC, is connected to the positive channel of the breadboard's power rail. The DHT, which is just in here, which might be a little hard to see some of these connections, that has an orange, a white, and a purple cable. So this is also using a 10k ohm resistor in there, so that's going to give us the optional pull-up configuration. In any event, the DHT's VCC terminal is connected to 5 volts via the power rail. This shares the power rail with the soil moisture sensor. So we're using the red jumper cable here to connect to 5 volts on the Arduino, and then we're sharing the positive rail. White for the sensor as well is for the digital signal. So we're connecting that to digital pin 2. And then we also have orange, I think it was. Yeah, orange connected to the negative channel. So that's going to be our ground. And for the LEDs, the anodes are both connected to digital input pins. That's 5 and 6. The cathodes have current traveling across two 220 ohm resistors. And then we have jumper cables following that to the negative power rail again, the negative channel, I should say. Now, the purpose behind this circuit is that it's going to be able to read the temperature, the humidity, and the soil moisture content of a medium. And then we are going to have some selection statements that will change the color of the lights for us. So the initial state is green, that reflects good. And then if the temperature, humidity, or the moisture content exceeds a certain threshold, the light will change to red. So most of this magic is sort of happening behind the scenes here. All right, so up the top we have a number of variable declarations. So we're using the DHT.h library again. We're defining our DHT sensor as using pin 2. We're saying that the type of DHT sensor we're using is a DHT22. The moisture pin gets a value of A0, so that is going to connect our analog channel. The green and the red LEDs are connected to digital pins 5 and 6. And then we have 3 different thresholds here that we'll use in our selection statement later on. And if the temperature was to exceed 25, for example, which we've set as our base, the light would change to red, and it's the same for the other ones. In terms of which of these is most likely to break the condition, or meet the condition, I should say, it's likely going to be humidity, because we can blow on the sensor and change that rather easily. Temperature does change a little bit, but that's a little hard to maintain a difference in, so we're not really going to be looking at that one. Next, we're going to initialize an object of the DHT class, and we're passing in the pin that it's using and the type. So that is pin 2 and type is DHT22. Then we have our setup function. So this is going to initialize all of our settings. We have the serial begin again. So that is going to say 9600 bits per second. And we're going to look at it in the serial monitor pane like we did last time. DHT begin, that's a method from the DHT class. And that's just going to initialize the DHT and get it ready to start collecting data. Pin mode sets the LEDs to output, so we're going to be sending voltages to these. And then we have digital write here, setting the green LED to on to begin with. Next, we are in the main loop function. And here, we're getting the current temperature and humidity of the room that we're in. So this is the sensor reading these values in real time. We'll perform some checks and make sure that they're a number. If they're not, we're just going to return the message failed to read. Now, the same here, we're going to read the moisture content of the soil that we have the probes in. Now, this value is not going to change too much, but just like in our previous task, we would be able to take that out and alter it, but we don't really do that. So the main one that we're going to be focusing on is the humidity. We're using serial print to sort of format our output here. So we're just outputting the result of the temperature, the humidity, and the soil moisture. And then down the bottom, we have our selection statement. And what this is saying is if the current temperature exceeds the temperature threshold, and the current humidity exceeds the humidity threshold, and the current soil moisture content exceeds the moisture threshold, then we will set the red LED to high and the green LED to low. So this will turn the red LED on and the green one off. And if any of those conditions are false, then we're just going to have the red light off and the green light on. In order to sort of see this in action, we can blow on the center here, blow hot air onto it, and that should change the color of the light. And it should also change the readings that we're seeing down here for humidity. Temperature will raise slightly, but soil moisture won't change. So there we have a red light there now, and we can see the humidity has increased. As the humidity comes back down, we can expect the green LED to come back on. Thank you.